Hi, in this video we will be discussing sub-interfaces and inter-VLAN routing. Sub-interfaces are logical interfaces associated with one physical interface. For instance, for router 1, we will have gig 00, and our sub-interfaces will be gig 00.10 and gig 00.20. These sub-interfaces will enable us to use inter-VLAN routing for VLAN 10 and for VLAN 20. So here we have router 2 that will be connecting to the multi-layer switch 1 in the 192.168.0.0 network, and then to the sub-interface gig 00.10. Router 2 is a layer 3 device. The multi-layer switch 1 is going to be a layer 2 device. So we will be connecting the layer 3 through a layer 2 to another layer 3 device using VLANs. Down here on router 3, we will be connecting to switch 1, a layer 2 device, to multi-layer switch 1, the other layer 2 device, and then to router 1, a layer 3 device. So VLAN 20 will be connecting one layer 3 device through two layer 2 devices to the other layer 3 device. Our two outside LANs are 192.168.10.0 and 192.168.20.0, and our local LAN is 192.168.0.0. Once we configure the routers with inter-VLAN routing, we will be using a routing protocol so that each laptop can talk to the other laptop through our layer 3 routers. So the first thing to do is to configure the sub-interfaces on router 1. Enable configure terminal, interface gig 00. Make sure that it is not shut down. Interface gig 00.10. This will be the gateway for VLAN 10. Encapsulation .1q. 10 is the label. IP address 10.1.10.1, and we are using a /30, 255.255.255.252. And we will also be configuring gig 00.20 for VLAN 20. Encapsulation .1q 20. And our IP address will be 10.1.20.1/30. Now the sub interfaces are configured on router 1. Gig 00 will need an IP address for laptop 1. We see that laptop 1 is on the 192.168.0.0 network /24. So interface gig 00, IP address 192.168.0.1/24, 255.255.255.0. our multi-layer switch 1 will need VLAN 10 on it, as well as VLAN 20, because VLAN 20 will be coming from router 3 and switch 1. Switch 1 will need VLAN 20 on it, but it will not need VLAN 10 because router 2 is not going through switch 1. The ports for the multi-layer switch will be trunk ports except for F01. F01 will be an access port for VLAN 10. That is how router 2 will access the 10.1.10.0 network. All of the ports on switch 1 will be trunk ports except for F01 and gig01. So in fact, switch 1 will only need one trunk port, F02. F01 will not need to be a trunk port nor access port because laptop 1 is not on VLAN 10 or 20. Switch 1 will forward traffic from laptop 1 by default to router 1. Gig01, however, will need to be an access port for VLAN 20 so that router 3 can be in the 10.1.20.0 network. Let's configure our VLANs on our multi-layer switch 1. VLAN 10 and VLAN 20. Our trunk ports will be gig02 and gig01. Interface range gig01 through 2. Switch port trunk encapsulation .1q. This command is needed on a multi-layer switch before you can configure trunk ports. Switch port mode trunk. And we will configure F01 as an access port for VLAN 10. Interface F01, switch port mode access, switch port access VLAN 10. We'll now configure switch 1. F02 will be trunk and gig01 will be access. Configure terminal, interface F02, switch port mode trunk, interface gig01, switch port mode access. I haven't configured the VLAN yet, but if I put the command switch port access VLAN 20 on gig01, it will automatically create VLAN 20 for me. Now that the switches are configured, we will need to configure router 2 and router 3. Router 2 will need to be 10.1.10.2 since the sub interface is 10.1.10.1. The interface is gig01. IP address 10.1.10.2, and it is a /30 255.255.255.252. And router 3 will need an IP address on its gig01 that will be 10.1.20.2. That is a /30 as well. 255.255.255.252. Now, router 2 should be able to ping router 1, and router 3 should be able to ping router 1. We will test to verify that we have correctly configured the VLANs as well as the sub-interfaces. Ping 10.1.10.1, and we have a success rate of 80% and now 100%. We will do the same for router 3. Router 3 is pinging through 2 layer 2 switches. Ping 10.1.20.1, 80%, 100%. Laptop 1 should be configured with an IP address of 192.168.0.2, and its gateway should be 0.1. We will test to see if the laptop can ping router 1 0.1, and we have replies. Now router 2 should be configured with the 192.168.10.0 network. Gig 00 will need an IP address of 192.168.10.1, and laptop 2 will be 192.168.10.2. So router 2, interface gig 00, IP address 192.168.10.1. This is a /24. And laptop 2 will be 10.2. /24, gateway 192.168.10.1. We will test ping. And we have replies. Router 3 gig 00 will be configured with 192.168.20.1. /24, and laptop 3 will be 20.2 /24. Gateway 192.168.20.1, and we will test ping. And we have replies. So now each laptop can ping its own gateway. Router 2 and router 3 can ping their gateway. Router 1 can ping laptop 1, but not laptop 2 or laptop 3, because we have not configured any routing protocols. So although this video is not a video on EIGRP, we will still use it to finish our network so that each laptop can ping the other. Enable configured terminal router EIGRP. Our ASN will be 100. Router 1 will need to advertise its own network, 192.168.0.0, wildcard mask. If you do not use a wildcard mask, the router will automatically translate a subnet mask as the wildcard mask. Router 1 will also need to advertise the VLAN networks 10.1.10.0, 255, 255, 255, 252, and 10.1.20.0. This will create the adjacency between router 1 and router 2 and router 3. For router 2, EIGRP 100, network 192.168, its own LAN 10.0/24, and the VLAN 10 network 10.1.10.0/30. We will see that EIGRP 100 now has a new adjacency with neighbor 10.1.10.1. That is the sub interface on router 1. Router 1 now should be able to ping laptop 2. We will configure router 3 with EIGRP. Router EIGRP 100, network 192.168.20.0/24, and network 10.1.20.0/30. Router 3 now has an adjacency with 10.1.20.1, which is router 1's sub-interface. Router 1, show IP EIGRP neighbors. And I see two neighbors, 10.1.10.2 and 10.1.20.2. And they have been up for 1 minute and 34 seconds and for 30 seconds. Show IP route. And I should see the 192.168.10.0 network in router 1. Routing table learned through EIGRP from 10.1.10.2, which is router 2. through gig 00.10, its sub-interface. Router 1 also knows about the 192.168.20.0 network, learned through EIGRP from the 10.1.20.2, which is router 3, through router 1's gig 00.20 interface. Router 1 should then be able to ping laptop 2 and laptop 3. To test, we will ping 192.168.10.2, which is laptop 2, success, and we should be able to ping 192.168.20.2, which is laptop 3, and we have success. Laptop 1 then should also be able to ping laptop 2 and laptop 3. Ping 192.168.10.2, and we have replies, and we should be able to ping 192.168.20.2, and we have replies. To see this in a simulation, I will ping laptop 3 again. The packet should go up to router 1. Right now the packet is on the 192.168.0.0 network. From router 1, the packet will then go to the 10.1.20 network. Through inter-VLAN routing, the packet is now in VLAN 20. It will reach router 3. The packet will then be routed to the 192.168.20.0 network. Laptop 3 will then reply. It will move to the VLAN 20, up to router 1 again, back down to the 192.168.0.0 network. We will do one more simulation where laptop 2 pings laptop 3. The packet right now is in 192.168.10.0 network. From router 2, it will go into the VLAN 10 subnet 10.1.10.0. Router 1 will switch it to VLAN 20 10.1.20.0. It will reach router 3, which will then move it to the 192.168.20.0 network. Laptop 3 will reply to router 3. Router 3 will move the packet back to VLAN 20, up to router 1, who will move it into VLAN 10, and send it back to router 2, who then moves the packet back to laptop 2 in the 192.168.10.0 network. That is it for sub-interfaces and inter-VLAN routing, and for a brief introduction to EIGRP.